Good morning, good afternoon, and good evening. Today we're going to cover the last subtopic of topic 3 thermal physics called thermal processes or processes. Conduction. Conduction is a type of thermal energy transfer where energy is transferred through a material. Recognize and name good and bad thermal conductors. A good thermal conductor will transfer energy quickly from the point where the object is heated until the whole object is warmer and the other end has a higher temperature. Bad thermal conductors, good thermal insulators, they're inversely proportional or something like that. On the other hand, will transfer energy slowly. Fluids are poor thermal conductors. Real-life materials that are bad thermal conductors include plastics, most fabrics, and wood. Most metals are good thermal conductors. And solids are good thermal conductors. Mainly. Experiment to demonstrate conduction. Attach identical paper clips at regular intervals to a metal rod using blobs of wax or other adhesives. 2. Hold the metal horizontally in a clamp stand. Using a Bunsen burner, heat the side of the rod with no paper clips attached from the very end. As time goes on, energy is transferred along the rod by conduction, and the temperature increases along the rod. 4. As the temp increases along the rod, the wax holding the paper clips in place will gradually melt, and the paper clips will fall, starting from the paper clip closest to the point of heating. This clearly illustrates conduction. You can test the effectiveness of other materials as conductors by repeating this experiment with the rods of other non-flammable materials. The faster all the paper clips fall from the rod, the better the conductor. Explanation of conduction in solids in terms of molecular vibrations and transfer by electrons. Conduction is the process where vibrating particles transfer kinetic energy to neighboring particles. In a solid, the molecules are held tightly together, so when one molecule vibrates, it collides with other molecules nearby, and the vibration quickly passes from molecule to molecule. This process continues throughout the solid, and gradually some of the energy is passed all the way through, causing a rise in temp at the other side of the solid, which was once the cold side. It's then usually transferred to the internal energy of the surroundings or anything else touching the object. 3. Metals conduct heat so good because the electrons are free to move inside the metal. At the hot end, the electrons move faster and collide with other free electrons, transferring energy. These other electrons then pass on their extra energy to other electrons and so on. 5. Or just 0.5. Because the electrons can move freely, this is a much faster way of transferring the energy through the metal than slowly passing it between vibrating neighboring molecules. This is why heat travels so quickly through metals. Convection, the process where more energetic molecules of a substance move from a hotter region to a cooler region and transfer energy as they do. Yeah, the only difference is the molecules aren't moved from their fixed positions. Yeah, that's the only difference. Recognize convection as the main method of energy transfer in fluids. Molecules in fluids are free to move about, unlike solids. This allows them to transfer energy by convection. Relate convection in fluids to density changes. I'll show an example of convection and like the density change that happens because of the energy transferred that causes the convection. And in this example, it's an electric heater. So energy is transferred from the heater coils to the internal energy of the water by conduction. Initially, the water near the coil heats up and undergoes thermal expansion, becoming less dense. The reduction in density means that hotter water tends to rise above the denser, cooler water. As hot water rises, the colder water sinks towards the heater coils. This cold water is then heated by the coils and rises, and so it repeats. You end up with convection currents going up, round, and down, circulating the energy. Experiments you can do to see convection currents. Place some purple potassium permanganate crystals in a beaker of cold water. Aim to put the crystals to one side of the beaker. Use a Bunsen burner to gently heat the side of the beaker with the crystals at the bottom. As the temperature of the H2O or water around the crystals increases, they begin to dissolve, forming a bright purple solution. This purple solution is carried through the water by convection and so traces out the path of the convection currents in the beaker. In convection, molecules move from hotter areas to cooler areas. I'm just saying that again, even though it's obvious from the slides before. Radiation, method of energy transfer that does not require a medium to travel through. Infrared radiation as the part of the electromagnetic spectrum often involved in energy transfer by radiation. Transfer by radiation is the transfer of thermal energy by infrared electromagnetic waves. All objects are continually emitting and absorbing infrared radiation. Infrared radiation is emitted from the surface of an object. All objects hotter than its surroundings emits more infrared radiation than it absorbs. More thermal energy is being transferred away from the object than transferred to it, so it cools down. Oppositely, objects that are cooler absorbs more infrared radiation and it emits, so it warms up. Describe the effects of surface color, black or white, and texture, dull or shiny, on the emission, absorption, and reflection of radiation. Surface, black and or dull. They're good at absorbing and emitting more and quickly, but bad at reflecting. White and or shiny. They're good at reflecting radiation, but they're really bad at absorbing and emitting quickly and more. Interpret and describe Leslie Cube experiment and similar experiments to investigate the properties of good and bad emitters and absorbers of infrared radiation. Here I have two videos for you. One of them is about Leslie's Cube, the one on the most right. Everyday applications and consequences of conduction, convection, and radiation. On the leftmost picture, we see a radiator. What it does is it heats up the air and it makes it go upwards. It becomes less dense, like in convection, and it goes down again. It creates a convection current. And another one is a refrigerator. So what we have here is the warm air rises and the freezing unit cools it down, and it creates a convection current as well. You have to remember, I remember for an exam I did last year that they're gonna ask like, why do they put the freezing unit at the top instead of the bottom? You have to say at the bottom, there wouldn't be a convection current created because air wouldn't be able to rise. It would just stay down there. Conduction. So we have a pan here and heat is applied to the bottom of it. The energy spreads through the metal by conduction, and the metal surface is at the same temperature. This allows it to cook the food because the energy from the heat applied is able to be transferred to the food particles, which end up denaturing the bad stuff you don't want to eat. And got electrical wires. Radiation, we got microwave, which emits infrared radiation to cook your meals, and the sun, which emits infrared waves for your plants, for photosynthesis. It's really important. When we want to reduce thermal energy transfers, thermal energy transfers can also waste energy that we want to keep usefully. Thankfully, there are some ways that we can reduce these thermal energy transfers: cavity walls, loft insulation, double glazed windows, and drought excluders. These are all in homes. Most importantly, you should know about the vacuum flask because that's what they're going to examine you about. Vacuum flasks. How do they reduce heat transfer? Convection. Empty spaces created by the double wall in a vacuum flask hinders the convection. The conduction. The vacuum-like space created by the double walls, which has less atoms, reduces the amount of conduction which takes place. Insulators on the vacuum flask exterior also reduces this heat transfer. Radiation. This form of heat transfer is reduced by placing a metal lining between the outer case and the inner chamber of the flask. So it reflects it. So these are my sources.